Hey, everybody. I'm Nick, the top line. This is Brandon. Hopefully you're here for the AVI, wait, I can't say AVI anymore, NSX Advanced Load Balancer software presentation. We're going to do a Getting Started lab. Any of you guys have load balancing experience? One, all right. Are you at least network guys? Okay, that's better, that's better. The vSphere guys might get confused somewhere along the way. So anyway, yeah, let's start moving through the slide deck. Excuse the fact that we have 800 laptops up here. It's kind of a little of agenda of what we're going to talk about today, just in the beginning, introduction, constructing lab experience, and then we'll get into the lab itself. So 3 people worked on this lab. It's me working on the actual pod, the nerd bits itself, and then I got these other 2 guys helping me out with the manual stuff. They also do all the quality checks on the lab, so if it's broken, it's my fault, but they should have caught it. So like Brandon, Solutions Architect, me, Product Manager for AVI. We will have to go through a couple marketing slides. This is forced upon me. Oh my God, and it's a build out slide. I definitely apologize for this. All right, so AVI is a software defined load balancer, and what that means is, other than buzzwords, is that you can basically deploy us anywhere. So we have a lot of flexibility by being software only. You're not constrained to a box. We do have the control plane and the data plane separate. They do not have to be in the same location. They can be in other locations. We do have some minimum requirements for latency and stuff between the 2, but as far as ecosystems, they don't need to be the same one. You can put a controller in vSphere, run containerized environments, public cloud environments, bare metal environments, all from that same controller in vSphere. There is nothing saying they need to be in the same spot. And then since we're software defined, we do everything API first. Anything you do in the CLI, UI can also be done through the API. They actually send API commands as for all of that, which enables us to have some automation, observability, orchestration, all of those things. All right, so product capabilities. So I mean, at the end of the day, we're a load balancer proxy, which enables us to have a lot of ability to add on things like analytics and security policies and stuff. But it is a load balancer. It's meant to spray packets. So local traffic management, global traffic management are probably the 2 things you would most associate with us. And then application security and WAF is around like bot detection, web application firewall, WAF, and then a little bit of DDoS. We're not a volumetric DDoS blocker. If you try to use us for something like an Akamai or something like that, it's going to fall over. You just don't have enough inbound circuits and enough SEs to handle that kind of load. So we are kind of like a second layer WAF. And container ingress services. So that's actually a later lab, our 04 AKO lab, which is tomorrow. We can talk a little bit about how we automate some of those service creation for Kubernetes applications. And then, like I said, software-defined platform enables the orchestration elasticity, so you deploy your load balancers out there in an active-active fashion. As you start to see load for your application increase, with the click of a button, you can scale those out. You won't take any traffic impact. It'll just start sharing that load across the other service engines. And also for failures, if you wanted those. So we kind of operate, we have what's called a buffer SE that, we'll talk about this a little bit later in the service engine group section. But that buffer SE is basically kind of like a RAID 5 that will watch. One of them dies, the other one starts taking over the load. It's a very quick failover. That's in the high availability and self-healing. They're kind of close to the same thing there a little bit. And then automation being API first, obviously we support all of the major Terraform, Ansible, Python, Go. We're working on some VRA stuff right now, so we got pretty good automation story there. Both of us do a lot with that, so we can talk a little bit more about that if you want. And then, this is out of date. It's actually called Cloud Connect now, or Cloud Console now, sorry, instead of Pulse. And this is what we call, it's kind of like a value-added collection of SaaS services. So what the big one is centralized licensing. So you've got a pool of licenses, all the controllers can consume it, instead of the old way where you had a license per controller. And then it also lets you do the real-time application security database downloads, like IP reputation, different providers, like GeoDB providers, who the cloud IP ranges are, stuff like that. And then we're starting to add some dashboarding features in there. So all of your controllers register with that Pulse service or the Cloud Console service, and then we'll start doing kind of like an inventory so we can see like a ratio of secure virtual services or insecure virtual services, how are your controllers running from a memory and CPU footprint, kind of like a quick overview pane of glass. And then we've got a pretty good roadmap for things we want to add to that in the future. It's fairly limited now, but it's going to be getting better every day. Analytics and observability. See, that's the problem with build-out slides, is I didn't know that was coming. Analytics is probably the core functionality that would draw somebody to Avi in the first place. When you see how easy it is to troubleshoot things and you see the log capabilities we get right in the product, it's like significantly better than a lot of the competitor products. You don't need to be doing TCP dumps. You can get full header collection and see log, how long connections took, all kinds of error information right in those logs that are built in. And that really is kind of our claim to fame. It's probably the best part of the product. And then we're starting to add more and more behavioral machine learning type stuff to it. Right now the machine learning stuff kind of mostly relates to the WAF, where we can start learning the correct behavior for an application. We call it positive security. We use the machine learning to be able to apply positive security to a virtual service, where we can actually go in and watch the traffic, determine what is correct traffic and incorrect traffic, and then it will basically fail closed. So the only traffic that's allowed is the traffic that you make rules for, and everything else is blocked. And that is basically impossible to do, because your developers will never give you a straight answer on what is supposed to be open and what is not. So you need the machine learning to figure that out for you. Constructing the lab. So this lab is kind of turning into my third child. Do I have the diagram in here? This isn't the diagram. So there's never enough time, and I'm not very good at details. So what I've tried to do is make this lab automatic. Historically, hands-on lab pods are something where you start in like March or April, and by about June, you can't make any more changes to it. And that doesn't really work for me, because I miss things a lot. I know it's fatal flaw. So I have made it so that this stuff kind of gets built dynamically on startup from a Git repo, and then when I find things that I've inevitably screwed up or didn't have correct, I go into there and make the Git change, push it, and then the next time a lab spins up, it'll have the updated code. That's kind of a new thing for hands-on lab pods, but it really makes it easier to cover your tracks. This lab is designed, so the very first year we did hands-on lab, we had it based on NSX, and then because the pod size was so large, for having 2 sites in order to show GSLB, it was very hard to manage. So we pulled NSX out, and now this year we've managed to add it back in. So this is going to be designed on NSXT Cloud, so I can kind of explain the differences between how Avi operates with NSXT and vSphere, and be able to show that stuff this year. Like I said, most of the configuration of Avi happens at startup. We used to have predefined SEs, we don't have that anymore. So depending on how quickly you get into the lab, for you guys it should be fine for the show, but if you were doing this on your own at home, there's a chance that the SEs won't be up yet. That's because we build them all dynamically, and it's easier that way than trying to explain to your controller why your SEs went on vacation for 6 months and then turned back on, and now, yeah, so it's a disaster. We try to gather content ideas from the field team and from customers as to what the common pain points are, and then kind of build lab scenarios around that. That kind of happens more in some of the more advanced labs. This one is just kind of a comprehensive overview of Avi. NSX Advanced Load Balancer, sorry. So we'll go over the cloud connector configuration, what cloud connector means from an Avi perspective. We'll talk about applications. We're going to have Brandon talk about applications. I'll talk a little bit about service engine groups, scaling, and then we'll get into app policies, which is kind of another meaty part of Avi where you have a ton of functionality. So if you've ever played with an F5, usually F5s are designed to be professional services dollar generators with iRules. We've tried to eliminate something like 80% of iRule use cases with clicky buttons and checkboxes inside the policies. So there's a zillion things you can do in there. And then we'll go over application troubleshooting toward the end. Move it out. I don't know if I can without breaking it. You're hearing beard noise? These things are terrible. All right. We're going to loosely follow the content. We'll try to follow it as close as possible, but this lab is super long and we will not get through all of it if we do that. So we're going to try and do this very quickly. We're going to, like I said, cover the architecture, cover the difference between the cloud connectors, and cover the basic ways that things work. If I end up talking through it at 1,000 miles an hour like I normally do, then we'll talk a little bit about some of the extra features you can do at the end with automation, and security, and global server load balancing. We do have a total catalog of 5 labs where we can go into the specific use cases. Obviously start with the getting started, and then as you get more familiar with it, you can try the GSLB lab, the WAF lab, Kubernetes lab, or migration. Since we went back to NSXT Cloud this year, we did add NSXT migration. There's a lot of concern that since NSXT Load Balancer is going away, how do we get from there to Avi? We have migration scripting for that. So we can show you how that stuff works in practice, and you can play around with it. We're not to the survey yet. All right. So probably start your labs now. Hopefully when you get into this lab, you get a green ready. If you don't, let me know, or let Brandon know. Also, Brandon, to answer our question, hour and 15 minutes, so they don't give us enough time. I think you do get 1 extension, though. 1 extension, 1 extension. All right, so let's open up this. There should be a bookmark in Region A folder for the controller. All right, we're just gonna have to zoom this. So usually in order to see everything on the screen, you're gonna wanna zoom it out a little bit. If you have a decent enough, I don't know what it looks like on your monitor. Can everybody see that? Okay, 80% is good for this projector. You should have a couple of virtual services up, the DNS listener and a demo virtual service. All looking good so far? All right, you'll notice the first thing you see here is a health score. You got a green and an orange. What that means is the orange one is getting traffic and losing some of it, and the green one is getting very little to 0 traffic. We'll talk more about health scores, but the big thing is don't strive for green. Usually it's going to be yellow that you're looking for. All right, so cloud connectors. Over in the infrastructure area under clouds, you'll see we've got our 2 clouds set up. We've got the default cloud, which is in there all the time. Some people use the default cloud as their main cloud, but we're using a name cloud for NSXT Cloud. We can see it's green, everything's good. If you go in here, so the cloud connector is kind of like the driver for Avi. So a lot of the automation from Avi comes from us talking to the infrastructure provider in order to spin up the service engines, handle security, like routing rules and firewall rules and stuff that might happen in like the DFW. We need to know how to talk to that. We need to know how to talk to AWS. That all happens in the cloud connector. So like if you do a create under cloud connector, you can see all of the various ones we support, and these all basically tell Avi how you're going to talk to that backend infra. So if you go in and look at one of these for this NSXT cloud connector, you'll see that this does not have a 2-finger. Oh, it does, okay. It's contextual, so the things in here, this is impossible to run. So contextual, so you'll see that there are things in here that are only related to NSXT. Once you start doing the AWS thing, it'll start asking for regions and VPCs and subnets. So all of these menu screens, most of the screens in Avi are based on the cloud connector type you're configuring against. So we'll show that more in service engine groups. You'll see things that are vSphere-y, like do I want to do memory or CPU reserve? If it were an AWS cloud, it would ask you the flavor, or the image flavor. So the point here is that all of these screens change based on the cloud type. And some of the other things that come from that automation from us knowing that infrastructure is IPAM and DNS. So we will configure these IPAM and DNS profiles in order for us to obtain IPs, keep track of IPs, create FQDNs for you. So we talk to the infrastructure to do subnet discovery for things like vSphere. If you use DNS provider, we can provide DNS, or we can delegate that stuff to Route 53, where we will inject a DNS record in Route 53, things like that. We good? You're just creeping up on me? So yeah, IPAM and DNS providers, they're to tell the cloud how to make the request for the IP and how to make the FQDN. And that'll get more important as we start getting in the application stuff. And then real quick about tenancy. We do have tenancy in Avi. Let me cancel out of this. We only have the admin tenant in this lab. You will create a tenant later in this lab. We probably won't do that as part of the workshop, but these are administrative boundaries, and the value here is if you've got an application team that wants to start doing their own, like for instance, they're the Kubernetes app team, they deployed a whole ton of different virtual services using Kubernetes, they probably want the analytics and the logs to troubleshoot. So you can create them an account that only has rights to their tenant using RBAC. We have granular RBAC now down to the object level, and you can give them permission to log into Avi and see all these troubleshooting things for their own. Very useful, but you need to remember that it is an administrative boundary. We can share service engines out of an admin tenant, or you can put service engines in specific tenants, but it's administrative boundary.
For those of you that are running F5, is equivalent to a partition.
Yes. Yeah, so that's a cloud account. You can, and then service engine groups we'll talk about later. Networks, you can see we've discovered some of this stuff from vSphere and NSX. These are our two segments that we have configured in NSX, and then we've determined the subnets for them. And then, of course, these VRF contexts. So a VRF for NSX actually maps to the T1. So it internally creates a VRF in Avi per T1. And then one thing I glossed over and forgot to talk about was the difference between vCenter and NSXT Cloud Connector. So NSXT's design for Cloud Connector is a little different than vSphere. We would attach to a T1 in a single connection, a one-armed mode. That doesn't mean you can't do two-arm transparent use cases like preserved client IP. Usually when people talk about one versus two-arm, they really mean preserved client IP. We do that through NSXT service insertion. That's a little bit different design than you would do with vSphere connector. In vSphere, we would stick it anywhere. We would stick a NIC in the segment where in the port group where we wanted the VIP to be served from. We would stick another leg into the port group where the servers were at, the backend pool members were at, and we would do it that way. And then if you wanted to do that preserved client IP, you would set us as a default gateway for those servers. They would route through us, and it would all be like that. We don't do that in NSXT. We do that through service insertion. In vSphere connector, you would do a layer 2 scale out method unless you had an upstream BGP router, which is a separate, more advanced configuration. So what happens is all the traffic comes in through a single SE, and then that SE is responsible for farming out to the other SEs that application is scaled out to, and it will rewrite the MAC address so the traffic comes back through it the correct way. In NSXT, we would program routes to do ECMP load balancing. Layer 2 is slightly less efficient, but you shouldn't think that it's a worse thing to use. There are reasons for using this way, There's a lot of different pros and cons. But layer 3 scale out is slightly better performing. We do have a limitation in NSXT where you can only have a certain number of routes on the T1. So if you try to do really large scale and you're connected to a single T1 and you start scaling things wide, you can very quickly run past that route scale. We're working to increase that in some of the future versions, but that is something we have to do in collaboration with NSX because it's a NSX limitation at this point. The other thing you can do with NSXT Cloud that you can't do with vSphere Cloud is you can make your pools be a security group, so then your dynamic addition and subtraction of members through the pool through the security group membership. We don't have that security group awareness in the vSphere connector. That would be done through manual edit removal of the pool members. And those are the biggies. Did I miss anything? Are you ready to talk about applications? So Brandon's going to go a little bit through the application wizards, and I'll try to chime in with color commentary as we go. So for you guys following along, you'll probably want to move to those, where he's at there. Create basic virtual service, basic app A.
Yep, page 48 it looks like. All right, so to create, there's two modes when it comes to building virtual services. There's a basic and an advanced. So if you go to applications, virtual services, and then you're going to click on create virtual service and then basic setup. So the basic setup is a very simple wizard, but first you're going to select your cloud. So we want to go to the Site A NSX cloud. Our VRF is going to be that T1 gateway Site A. And then for the name of this one, this is also in your lab guide, but it's going to be basic-app-A. And for the basic, you can select 4 application types. They're going to be HTTP, HTTPS, L4, and L4 SSL. So as you click through these, you can see you have your services port, When you click on HTTPS, you can select your port and then also a certificate. For L4, just the port, and then for L4 SSL, you can select your cert again. So we're going to do a HTTP. Our VSVIP, that is going to be your IP address that is a part of this virtual service. So we're going to come in and create that VSVIP. You can see that the name is pre-populated with the virtual service name with VSVIP appended. Our cloud is the NSX cloud. We do need to select our tier 1, which is going to be the only selection, the tier 1 gateway site A. And then for our, to add that IP address, you have a couple different options here. We have IPAMs already configured in the cloud, so therefore we can do auto allocate. That's where that's going to pull that from. We do want an IPv4. We do support IPv6 and both of them. And then select your IPAM or your network. And then the 172.16.110.0/24 network. And then you go ahead and save that.
So this is what I was talking about earlier with the IPAM profiles, is when you define an IPAM profile, you can tell the available segments and subnets that you can build your virtual service from, and then that's how those boxes get populated.
Yeah, and for IPAM, we do support several different ones. We have a built-in Avi one. We support info blocks. So there's lots of different ways you can do this. And we also want to create a FQDN for it. So if we go to DNS, we'll click Add. The name is already pre-populated, so pretty much you just have to click Add and then Save. And then you can see that down here you have one name in there. So if you click Save, next for your servers, with the basic app, it's going to automatically create the pool, and it's going to be the virtual service name with pool appended at the end of it. You could use an IP range of FQDN, an IP group, or security groups. So for the lab, it is 172.16.210.10. And then all we're going to do is click Save. It'll first come up red. It takes just a minute. If you hover over that, you can see that it is green. So if I click on that virtual service name, you can see all the information about this virtual service now. So you can see that we grabbed a 110.52 IP address. Our traffic is enabled. We're running on service port 80. This is our FQDN. Cut off a little bit. The service engine that it was placed on, the application, and I did forget to mention that when you select those, it's going to, like, you select the HTTP application type, it's going to put in the default network profile for that. So if I want to go to test that traffic or that VIP,
That bad lab admin who didn't clear that browser history.
maybe this will work. All right.
So the important thing to remember about the basic versus the advanced wizard, this is probably the only time you're ever going to use the basic wizard. If you actually get Avi in your environment, you will predominantly work in the advanced version, mostly because the basic one is so basic. Like, it automatically assumes that the port for the virtual service is the same as the port that the backend servers are running on, and it makes a lot of assumptions about things that you would normally configure in the advanced wizard. So, good way to get started, but in reality, you're probably not going to use it much.
Yeah, bear with me. It's not copying and pasting. So, is that right, Nick?
No. corp.vmbeans.com.
Region 01A.
And then it's corp.vmbeans.com too. Then you missed it. There you go.
All right, that was
There
more
we
painful
go.
than it needed to be, but there you go. So once I got the FQD in, you can see that it did pull traffic. So I can go back. I can click on the logs into this virtual service. And then your non-significant logs are enabled for the first 30 minutes that your virtual service is up. You can tailor that, just change that and go into the virtual service, which I'll do on the advanced one. but just that first 30 minutes when you first spin up that virtual service.
And that's a performance-oriented thing. That greatly increases the volume of logs that come in for the virtual service. So we don't recommend you leave that on for production virtual service. You'll leave it on in the beginning to make sure everything's working, and then if you need to troubleshoot a specific issue.
And as you can see right here, I expand that log out, and there's all sorts of great information that will help anybody that's troubleshooting any issue. So you can see your client IP address is 192.168.110.10. I came in on port 5536. I'm running on Ubuntu. I used Firefox. I can see the virtual service IP address that I connected to, even the virtual service, the service engine IP that connected to the backend server. I went to that basic app pool A pool. You can see your request information, all of that. So give them a few minutes to do that.
All right, let's talk about advanced mode, the real mode.
Yes, this will probably be the one and only time you use basic. All right, I'm going to go back to my virtual services. I'm going to click on virtual service and then go to advanced. Select my cloud again.
Do you want to advance the manual to the right page? Up a bit.
Okay, that looks like the advanced starts on page 64. Thanks, Nick. All right, then we're going to select our cloud. Let's select that VRF, go to that tier 1 again. And so for advanced, you're going to see that you have a lot more options. There's 4 different tabs. There's settings, policies, analytics, and advanced. And it'll walk you through them. So for our advanced, it is going to be advanced ADV -app. All right, we have enable button, so this is just your master on-off switch for the virtual service. The traffic enabled knob is a very important one, so that is what's going to enable ARP. So you can run with your virtual services enabled and then disable ARP, so if you want to have your app teams test, you can go ahead and do that. Virtual service hosting, this is for SNI and EBH if anybody's using that. Same procedure for that VS VIP. We go into it, create a VS VIP. You're going to scroll down and select that tier 1. And then add your VIP by selecting that allocation network. And then the IPv4 subnet. And then scroll down and add that DNS FQDN.
So you might have noticed the mix between UI flavors here. You've got a little bit of the VMware Clarity UI and you have our original UI. We are in the process of moving all of that to the UI, but the sheer number of configuration screens means it's a multi-year process. So we're slowly getting there, and since this is the most complicated one, it's one of the last ones for us to move.
And so for our profiles, you can see over on the right, our TCP UDP profile, there are quite a few of them in here.
App profile.
Oh, sorry. Well, I can go through this one real quick. But so your system TCP profile is just a default profile. We would always suggest for you to not modify the defaults. If you're going to create application profiles or you need to tweak something, create a new one. But I would just leave it in auto learn. There's very few use cases I've seen to move it to custom, but there are lots of options that if you need to, change your idle connection timeout or idle duration, TCP wait timeout, things like that. You can go ahead and do that.
If you have some old janky apps that require super long live connection times, looking at Horizon, you might need to tweak those a little bit. Otherwise, for the most part, we would recommend leaving that stuff in auto learn.
Yep. So for our application profile, we're going to use the system HTTP. And so this is, I would say, the application profile is probably the meat and potatoes of your virtual service. A lot of our native functions, for those of you that are possibly moving from F5 and you have a lot of iRules, a lot of obvious native functionality is built into these application profiles. So if I scroll down like connection multiplex, that would be one connect in F5. Your detect NTLM, WebSockets, your X-forwarded4 is down here somewhere. Oh yeah, right here. I'm going to use this new AI myself. So your X-forwarded4, the alternate name. When we get into security, this is a really good one too to know. And I guess my first warning would be is if you don't know the app or if you don't know if the app is ready for SSL everywhere, don't just go in and click SSL everywhere because you want it to be super secure. We've seen it over and over again that people go in there, click this, and then it breaks their app. So make sure that you test everything before you do this.
The thing that's going to get you is the bottom one, HSTS.
Yeah.
Lots of apps are going to tank with that turned on, for better or for worse. Just remember that's the checking box you're looking for.
Yep. So right now you can enable your 80 to 443 redirect, your secure cookies if you want HTTP onlys, rewrite your server redirects to HTTPS, your exporter protocol, or like Nick was talking about, the HSTS.
So that HTTP to HTTPS redirect, if you've come from an F5 world, usually you would create 2 virtual services, one to cover 80 and one to cover 443. We have at least 3 ways I know of to do HTTP to HTTPS redirect, and this is just the easiest one.
Yep. So for our client certificate or client SSL validation, if you want to do Maslow, you could do that there. We can get into compression. We do support that. So your compression settings, caching, DDoS. I don't know if you want to chime on those or
About DDoS. So these DDoS things, there's 2 different parts of DDoS in the product. One where we actually, so there are certain things by default, DDoS attacks like SYN cookies and stuff that we would do by default. Most of the DDoS settings in here are just sane limits for like header sizes and whatnot. We do also do thumbprinting as a security mechanism so that you know when you're being attacked by a certain DDoS. What did you switch? Okay, like I was saying, DDoS, these are mostly parameters to, maximum header size is the amount of time, if you're doing like a slow post, you want to make sure that the connection's not long-lived. Those are the kind of things we would block with these DDoS parameters. And then there are rate limits, the granular RBAC stuff. If you scroll up a little bit to the true client IP, we can talk about that real quick. So when we do these labs, we try to do traffic generators that make it look like we're coming from all kinds of different locations. And usually I do that through network spoofing, which is, of course, inconvenient in this very routed NSX world. So true client IP is a feature that we have. It's basically so if you have multiple proxies in a row. So say you've got Cloudflare doing your big DDoS protection, it's going to add an X-forwarded-for header, but it's going to look to Avi like everything is coming from a single set of IPs that are just Cloudflare IPs. So it's going to affect your load balancing. It's definitely going to affect your awareness of what's coming from where. So true client IP is a newer feature where we showed that it's looking at X-forwarded-for. We can take into account the X-forwarded-for headers that are already there so that we know where it originally came from your first WAF provider. And then we would stitch on another IP that was the Avi IP after that, so you get a whole list of X-forwarded-for headers. And then that also makes it so that we get better load balancing, you get better analytics, and then I don't have to do spoofing for the traffic, which is the real reason why we're using it in this lab today.
Okay, so we're not going to be enabling WAF on this, but for your web application firewall, this is where you would enable that profile. And also we have a bot detection policy now.
Does it still say beta on there?
It does.
That is not beta anymore, that's GA. Somebody needs to put the little sticker over that piece. But basically that is a newer feature, obviously since it still has the beta tag there, that helps us to know whether or not the traffic coming in is good bots, bad bots, or dangerous bots, and then you can apply detection policies and stuff based on that.
Yep. And then for services on this one, we're going to do a little bit more advanced. We're just not going to have port 80, so you would click on your switch to advanced, and then here you can now put a range of ports in here. And for this lab, I believe we're doing...
I think we do 80 to 81 or something.
80 to 85.
85?
Yep, 80 to 85. We do support HTTP 2, so you can select that right there. And then also... keep that ain't working.
The 5's broken? There we go.
If you do select this SSL box, you'll see down, well, you didn't see it, but right here, your box down here will appear so that you can now select your certificate and then also your SSL profile. The SSL profile is just going to be a collection of accepted ciphers and versions that you want to use.
So if you had an old legacy app that needed TLS 1.0 or 1.1, you would add that here, and then if you had an advanced application that was, modern and stuff, you could put TLS 1.3 in there. TLS 1.2 is still the most common, so it gets to be our default. We also have a pretty narrow set of ciphers these days because all of the CBC ciphers were hacked a few years ago or whatever with GPUs. So now we try to select only the most secure ciphers, and you would turn them back on in here if you had a legacy app.
But For this one, we're not going to do SSL. We are going to add one more port, and then we're going to do, it is 8080. And you could also select to override. So if you had a specific application profile that you wanted to use for a specific port, this is where you could do this override. And then you could also override the TCP port too.
Horizon's a good example of that, where you will have your front end VIP be the layer 7 one that does all of the XML communication with Horizon, and then that same IP will flip over to layer 4 for doing the blast and the PCO IP stuff on the same IP.
And then we will come over and create a pool, not use that one. So when we create a pool, it's automatically the virtual service name with the pool appended at the end. We need to leave it in. The first thing we need to do on here is select that tier 1 gateway. For load balancing algorithms, though, we do support quite a few. So there is consistent hash, core affinity, fastest response, fewest servers, least connections, least load, and round robin, and topology. So our default is the least connections. You can also enable real-time metrics if you want. Real-time metrics, so by default is what? Every 5 minutes.
Yep.
And then real-time metrics is it pulls the metrics every 5 seconds instead. It is more resource intensive, so I guess use sparingly or make sure you're paying attention in a prod environment. Click on, we'll go to servers. For this one, we're going to add 2 servers on here. It is going to be the 172.16.210.11.
Why do you keep doing everything? It should be 110. 210 is the second range.
Oh, because that's what I wrote on my notes.
So this lab, the infrastructure is designed to be able to also support a GSLB lab where you could do 2 data centers, but it's the same infrastructure, so it's a little confusing sometimes. But 110 is the primary site.
Okay, and then we can go ahead and add those. You'll see that it will populate down there.
Port should be 30,001, I think?
Yeah, I did miss the ports.
So you can either explicitly provide the port per server here, or you can enter a default server port that will apply to all of them.
Yeah, you would just select that right there. But we're going to do a default port, which that would be right here. So that's going to be 30,001.
Yeah. You got enough zeros there?
Nope. This keypad. And then for a health monitor, we are going to be using a system HTTP. So there are quite a few by default. HTTP, HTTPS, ping, TCP, UDP. We can get into SCP, DNS. There's quite a few. I can get in and expand on a little bit on this. So by default, our send interval is every 10 seconds. Receive timeout is 4. You have to pass 3 successful checks for the virtual service to come up. For your health monitor port, we're just going to use that server port, and that server port is using the default port. So you see how all that maps together. That 30,001 is what the port will be hitting. Your user input for your client request header, and then converted, what the value is going to look like. The use exact request, this inserts, it's 3 fields.
It's the carriage returns and stuff that it's
Yeah.
going to do. A lot of the fields that you have to do to make an HTTP connection work will automatically be inserted by us, but some apps require you to do tweaks to those, so then you can do use exact request, and we won't add a bunch of extra stuff in there.
And then for this health monitor, we are looking for either a 2x or a 3x response to mark this up.
Something to note is that HTTP monitor is a layer 7 monitor. There's also layer 4 monitors that will not do nearly as many checks. You do need to have those good responses at a layer 7 level for that HTTP thing to work. So ping might be working fine, but that doesn't mean your application is healthy, which is why we use these ones. You also have the ability to do custom external health monitors, where if you have like a specific database query like you want to do in Postgres, we can do that as a scripted add-on. And then there's a little bit, I think it just shows up as custom external monitor or something like that, right? Yeah, system external. So you'd use that system external one, and then in that profile, you would give it the path to the script on the controller, and it would run it and log in, and hopefully the query worked and everything's happy.
Yep, exactly. So for persistence, this is where you would select your persistence profile. So we do support client IP, HTTP cookie, your app cookie, TLS. So you configure that here.
And if you guys aren't familiar with persistence, it's just to make sure that you get sent to the same server every time. It's usually for apps where you have to log in that need to maintain a state. Otherwise, you would get load balanced to the server that didn't know you logged in, and then you're in trouble.
And that should be good on the pool. So if you click next, we're going to move into policies, but I'll get into those in a little bit.
And these definitely require their own chapter. There's a lot here.
Yep. And then for analytics, there is a lot to analytics. This would be, so if you're trying to tailor, this is where you're going to generate your health scores from, is your configurations in here. And let's say you have you're logging into a website and you get a 401 response, but that is, that's how the app team actually designed that. So you can come in here and you can exclude things like that because that's going to ding your health score. So this is just where you're going to help tailor that. We get into client app decks. So this is your toleration factors for those. If you're, you want to exclude like server connection resets, you could do that here. Retransmits, things like that. Just really customize this to your app so you can see what your app's doing. That's what you're going to do in the application profile or analytics profile.
This is more for the people who need to chase the elusive green dot. There are values to health scores. In fact, can you click? Do we have a yellow health score so we can show how to look at what it's being dinged on?
I can.
I suppose we got to save it first. We'll come back to that after we save it.
Yep. So log all headers, I want to show you guys how to do a log all header. So you would enable that here. So that's going to capture every header that is sent from the client to Avi, and then from Avi to the server backend, and then back your responses as well. And then your non-significant logs, so if you wanted them to be enabled for a little longer than 30 minutes, you would do that here. You could put it 0 in there, and that would be infinite. Okay.
Putting 0 for like 15 busy VS is a good way to murder your controller. Just FYI.
And then when we get into advanced, so if you want to check like performance limits, if you want to rate things here, rate the number of new TCP connections or new HTTP requests, you could do that here. Define your time period, and then if you want to report it, if you want to drop it, or send a TCP reset, you could do all that here. So auto gateway is a feature we have to make sure that we send the client connection back to the source MAC address, not to the default gateway of Avi, to make sure that the traffic is always going to flow. So you could have a no gateway or the wrong gateway for Avi, and your traffic is still going to flow correctly. If you're using BGP, this is where you would enable this here. So use VIP via SNAT and advertise VIP via BGP. For an L2 deployment for Avi, we can scale up to 4 service engines wide. But when it comes to BGP, it depends on the upstream router or the capabilities of that upstream router. But you can go up to 64 service engines wide. So you can really just go expand horizontally and just get a lot of throughput.
We should note that for NSXT, we also plumb static routes to do ECMP, but you don't need to do the checky box. That's the default behavior, is us plumbing a /32 per destination service engine. So as you scale out, there will be a route for each service engine, and then it'll just do equal cost between the 3.
Yep. If you do have multiple service engine groups, this is where you would go ahead and change that. We just have the one default one, so we'll just click save on this. You can see that our virtual service did come up. And let's see if I can copy this one.
Some of our lab testers told us we should have bookmarks for these, and we were like, but then we're going to have 25 bookmarks, and now I'm starting to see maybe we should have.
So you can see that I hit that. Let me do a couple other queries just so I can show you the flexibility of this. So I'm going to do a couple curl tests.
Any questions while he's typing that out?
Yes.
Got to add the curl too.
Oh, yeah, thank you. So I'm going to do a curl-I. That's just sending a head request, so it's just a shorter response for you. If you remember, we did the ranges ports 80 to 85, so I just curled port 80. You can see that that came back just fine. I could do 80, 80, and that comes back just fine. And to demonstrate some of the headers, if I do a dash dash header, we'll do Avi rocks. And so I got a 200 OK. So I can come into my virtual service logs now. Go to logs. Check my non-significant logs. Refresh it. And it should be this last one right here. So I'm going to get those same analytics that you saw before. But now I have this view all headers because I enabled the log all headers. So when I click into this, I can see the headers received from the client, and you can see them there, and right there, that Avi Rocks header that I just sent. And then the headers sent to the server, so we sent that to the server. The headers received from the server, so the server didn't send that back. This field right here has helped me troubleshoot so many issues between app teams, the network team, on the customer side, because the customer or the app people say, hey, we are not inserting this header, and it's not breaking this, and vice versa. And this is black and white. Like, it is what it is right here. So this is a great one to have.
All right, so service engine groups. Service engines to us are cattle, not pets. We don't care about service engines. We give them bizarro names. We don't ever expect you to actually log into one unless you're trying to troubleshoot a problem. But service engine groups we do care about. This is the template that service engines get created from. So all of your parameters around CPU, in fact, I'll just show you. So you'll see real-time metrics again. If you want full real-time metrics, this is something you have to enable on the pool, the virtual service, and the service engine to get all of these really good metrics. But that means, man, I hate this laptop. All right. So we should quickly talk about the high availability modes. So we do support active standby, M+M, and active-active. Active standby is your F5 model where you have two appliances, one sitting there waiting, costing you thousands of dollars, and the other one actually doing something. If you need to run that, some applications like FTP would be a good one, need to run on that where it needs to be a very consistent path. Usually we would recommend you run in either active-active or M+M. These are active-active and M+M are largely the same. There are some defaults that are different with active-active, but the mechanism is basically there. M+M basically just means that you're going to be running with a certain number of service engines plus the buffer that I mentioned earlier. And then M+M would mean by default that you're only going to have a virtual service scaled to one service engine. You can change that default if you want, and then it starts to become more like active-active. Active-active enforces a minimum of 2 service engines per virtual service. So anytime you deploy a new virtual service, it'll automatically end up on 2. If you have administrators in the lab who don't want to blow a bunch of money on cores, using M+M and putting it on 1 is a great way to do it. But if you use that same service engine group and go to production and they forget to scale it out, and then you have a service engine that goes down and you lose your app, and then everybody's getting mad about that. So it's something to keep track of. But it's an important part of the way we operate for getting that active-active. But otherwise, you can see this stuff is all about the infrastructure. Dedicated dispatcher CPU is something we do when you go past 4 cores-ish. It's very traffic dependent. A lot of this stuff with load balancing is very art, not science, because there's just so many different kinds of traffic and so many different traffic profiles. But dispatcher CPU is something where normally you have a core that's called a hybrid core that will do the networking functions and the proxy functions at the same time. If you start getting a large volume of network packets per second because your app is very chatty or whatever, having a dispatcher core to handle just the network parts and leave the other cores to do proxies like SSL and redirect and all that stuff will help your performance. Usually that starts to have impact past about 4 cores. Compact and distributed just kind of has to do with how it lays new virtual services across the service engine group. Compact means it tries to fill one up before it moves to the next one. Distributed means it will try to evenly maintain virtual services across the group. And then you'll start to see that now we do the how we want to allocate memory for caching, how we want to do it for buffers. And somewhere in here in resources, you will see the CPUs. I don't know why I don't see it now. Oh, because sorry. I need to be in the right cloud.
Yeah, your configuration options are going to change per cloud. So,
Which that was a good example. So in a no-access cloud, we don't manage the lifecycle of the service engine, so obviously you can't set CPUs because that should have been pre-configured. But now that you're in here, in the right spot, you'll see memory reserve, CPU reserve. We don't recommend you go to production with one vCPU SEs. You can do it in testing, but we obviously have to do it in here for resource constraints that we have in the lab. And then the 8 gigs of memory usually revolves around GODB and stuff like that. Bot detection requires 8 gigs too, which is why it's higher here than you would. You can do a 2x4 SE is a good place to start as you figure things out. And then, all the very vSphere specific knobs. Like I said, if you go in here and you make an AWS cloud and you start showing these things, you're going to see flavors, you're going to see all of the AWS specific stuff in here. So yeah, service engine groups are a template for how the service engine should look. So I could show you I could show you a quick demo of the scale out and what it looks like in NSX. Let's see if I can click this super fast. You guys don't need to do this or follow along for this one. Just kind of want to show how that static route injection looks. So we've got this demo virtual service talking about health scores. This one's orange. If you go into the health score and you're... I'm not going to be able to do it on this one, but you can go there and click in that health. You'll get a little breadcrumb trail to follow that will show you specifically why we're marking it down, if it's an AppDex thing or if it's because you have a bad SSL certificate. In this case, it's because I did a past day time frame and it just came online about a few hours ago, so it sees most of it as being dead into the world, which is why it's orange. And you can see we're on one service engine here. If we log into NSX, so let's look at our VIP real quick. That VIP is 172.16.130.11. Oh, that was wrong. I'm not an NSX guy, so sometimes this is a little sketchy, me showing this stuff. Static routes. We got 4 static routes. All right, so we got our static routes. It's showing the IPs here. It's also showing the name of the VS VIP. This is something that Avi provided NSX with as far as information. So demo VS VIP. See, we've got a next hop of 1. We've decided we need this to be more highly available. We're going to hit the scale out button. You'll see it gives you the IP address of the VIP. The VIP and the virtual service are different. If you can share VIPs, but anyway, it's a separate object in the API. But you can either select a specific service engine you want to scale out to, or you can have it create a new one. We're just going to have it automatically select which one it thinks is best without creating a new one. And we're going to hit scale out. You're going to get this fault saying this should not be a red box. It should be an orange or a yellow box because it's not that scary. It's just saying it's programming the route. So we're going to cancel that. And we're already scaled out. And now we should be able to go back here into NSX and hit refresh as soon as I find it. I'm going to close it and reopen it. There we go. So now we see we got 2 routes here, or 2 next hops, showing that we scaled out to that second service engine. So that's kind of one of the beauties of Avi, is us being able to program those routes. Now we have equal cost multipath routing going to each one of those and double the performance, click of a button. So that's the flexibility and the elasticity in action.
okay, so for policies, and get back into Avi. Go to the right one. So this is going to be should be module 5, page 186. So that tab that I had switched, you guys can hear me, right? So, okay.
Went off. Okay, now I can hear you, and now you can hear me.
Okay. So going back to that advanced app, that policy tab that I did skip. So this computer.
It really is a hard to work with laptop. We're not bad at computers.
All right. So there's several different, I guess, flavors, if you will, of policy. So we have our network security policy. This is going to work over a TCP layer. When that connection is coming in before it hits layer 7, we have HTTP security and HTTP request, which are going to work at layer 7. Your HTTP response, and then data scripts. The majority of your iRules when you're migrating over from F5 to ALB, I do a lot of migrations. I've been on the field engineering team, worked with a ton of customers, and that's really what I do, so that's why I kind of always refer that way. But most of that can all be done in that application profile, those click boxes there, or your policies right here. So all UI clicks, no scripting anymore, up until data scripts. Data scripts are written in Lua, and I've not seen a use case that we can't do with Lua. It is very flexible. You do need to know Lua, so that is, it's pros and cons. We always try to make sure that we do things in the native functionality, and then policies, and then data scripts if we need to. I'll just talk about data scripts just for a little bit, but I want to get into it. There's a lot of options, and we're already 25 minutes left. So for functions for data scripts, we've got tons of functions. They are all documented here on this KB website. But as far as if you want to capture the VS client port, this is going to return the client IP address, and it's got a little snippet of what's going on right there. So these would be all of our functions, and then what my team's trying to do is we're trying to build iRule examples and then the corresponding Lua or data script for all of these. And we've got so many examples. We're constantly trying to add to these and update these. I'm happy to share these links afterwards if you guys are interested, but just, if you want to do a HTTP host heading data script, that's what your F5 iRule is going to look like, and this is what it's going to look like on AVI. So you copy and paste, put in your specific parameters, and you're ready to go. So pretty simple.
So if you're asking yourself why Lua and not something else, these scripts have to execute on every request, and Lua is extremely fast. If we stuck something like Python in here, you would kill your app right away. So it's a weird language. It's sometimes hard to wrap your brain around the way it works, but it is very, very fast.
So to create a new policy, we're going to click this green plus mark. And I'm not going to follow the guide on here. I'm just going to show you guys some of the options, do a couple curl tests just so you can see what's going on. But your rule name, so this would just be your administrative name. If you want to create a log entry for whenever this is triggered, so you have your matching and your actions. So for the matching options for your network security policy, you can match on your client IP address, any service port or IP reputation, and then your actions are you can allow, you can deny, or you can rate limit. We jump over to our HTTP security. There's a few more options on this one. So your client IP address, your service port, protocol type, your HTTP methods, version, paths. A lot of host headers, a lot of paths I've seen converted over here. Cookies, host header, IP reputation, bot management. Nick wrote the bot management part, WAF course. So if you have any questions about that, he's good with that. Your source IP, and then for the actions we can allow, we can close. You can enable NCAP and send that over. Rate limits, you can redirect to HTTPS. So out of the 3 ways that Nick was talking about, where we can do HTTP to HTTPS redirects, we do have that application profile redirect. We can also do it in policy, and then we can do it via data script. And then another action for here is if you just want to send a response. So if you have a specific range of IPs that you don't want, you can match those IP address and send a 403 and then upload your file right there. So quick and easy. So for HTTP request, you have a lot of the same matching, so I'm not going to read through those. But with that, we can redirect. So that would be your 8443 or things like that. You can modify the headers. You can add headers, remove headers, rewrite that URL, or you can content to a different switch, or content switch to a different pool. So I'm going to do that one. Just that's an easy one I can demonstrate for you guys. So my IP address should be 192.168.110.10. And we'll just go to the demo one. So this is that advanced one, so I currently have the advanced pool. So if I click save on this, and then save again, you will see that I now have 2 pools mapped over here. So I have the original one that is the advanced pool, and then I have the demo pool. So if I refresh this, go back to my logs, refresh it. So you can see that my IP address of 192.168.110 was handled by this virtual service engine, but it went to the demo pool, and that's because rule 1 was activated right there. It was triggered. So quick and easy for content switching. You can see exactly what happened.
If you're not from a load balancer background, content switch is a very common use case. You do all kinds of content switch redirects on paths. Like if you got your normal website that is a bunch of dynamic content, but you got a bunch of file upload or download servers that just do static stuff, you can have your /uploads or your /downloads go to that static pool, and the rest of the stuff goes to the dynamic pool, things like that.
And then for HTTP response, like I said, a lot of the same methods. We are going to have a response header here. I think HTTP status is different. And then we can modify that header, or we can rewrite that location header.
This is all about tweaking the return response from the server before it gets to the client.
And then for those data scripts like I was talking about, we can create a data script. There are a few default ones that we have. Those are for specific things, Horizon, things like that. You could enter a name, test, and then what I would do is I could grab, this data script, come down to add event. So this is going to be an HTTP request event.
You can see that's extremely comprehensive. We can run those scripts at lots of different spots during the connection setup. It just kind of shows you the flexibility or the weeds you can get yourself into if you start playing with these.
And if I could copy and paste, then I would paste it here. Yes, so, and how I know that is a HTTP, so if I come back to here, I can see that in, I swear that I said it in here. Does it not say it in the function?
That it's 7 versus 4?
No, that it's a HTTP request.
Oh, I think because that one you can use in more than one of them. If it is a specific one, it'll say it, but I think you can use that one in more than one method.
That is true.
So.
Okay, yeah, so you can see right here, this event is that, so that'll tell you what event you need to do when you're configuring that UI. That's HTTP response.
Things like client IP can be used across everything because it's a pretty generic one.
There any questions on policies?
Very powerful, a lot of options. Another one that he didn't mention was the access policies. Access policies are if you want to take an application that doesn't have an authentication layer and add one using Avi as the front end. If you guys get you're almost out of time, just click the extend button. I'm sure you guys have done that before. We support LDAP and SAML backends. You can use something like Workspace ONE Access to be your backend SAML provider and to enable authentication, single sign-on. It would handle two-factor authentication mechanisms. All that stuff is done through those access policies at the end there. Yeah, and then JWT token if you do OAuth token, stuff like that. The Kubernetes apps, that's all in there too. We talk about that just briefly in the Kubernetes lab too, on how you can add that authentication layer to Kubernetes apps. Good? So yeah, a zillion options. I do not expect you to even begin to work through those in this lab. We got 17 minutes? Yep. All right. So we've already showed quite a bit about analytics already, but I can go into a couple specific ones. So the demo virtual service, this is one that I've had running for a while with when the lab starts up, synthetic traffic starts hitting it immediately. If you guys go look at the logs, you'll see as they load. By benefit of that true client IP stuff, you can see we've got all kinds of different IPs in here. We can go into one of those and look at it. You can see this one came from Germany. Didn't really come from Germany. Came from the same box all the rest of it comes from, but that's all spoofed. So we basically just look like that front-end proxy. As we showed before, there's a wealth of information in here. This is one of the most valuable things you can do with Avi is have all of this information in here.
A lot of these are hyperlinks, so you can just click on them and it will create the filters, and I think that's where he was going to, is you have the filters over on this right side.
Yeah.
But you can click on the hyperlink, so you can come over here, which is nice because it's all together. So if you want to click on browser real quick, you can see every single browser type that's hit this demo virtual service since it's been up. So you got Chrome IE, Chrome Mobile, Firefox, iOS. So you can see exactly how many hits, what browser is hitting it.
Look at that nice even distribution. That is a testament to my Python skills right there. So one of the things that people use this for, obviously, is very quickly determining where the problem is in their application. And let me see, what am I looking for? Response code. We're getting a lot of 404s. We click into this 404, it's going to make the filter for us. All these response code 404s, and we can find out that that is all happening evenly across 2 applications. I have a sales demo of this where I don't have Kubernetes deployed servers that are identical to each other, where only one is missing the file, and you'll be able to go in here and see very quickly that only one of these is your bad egg. So being able to see very quickly, very easily where the problems lie with things like 404s and stuff is very useful for getting the ticket out of your queue and getting it into the application queue where it most likely belongs in the first place. You can do some of that stuff with, man, this is hard to work. Non-significant, usually you don't have problems in non-significant, but maybe you need to see some of the ways your policies and stuff are working so that you look at that traffic. Most of your heavy lifting is going to be done in the significant logs section. And then analytics showing a response time and timing and throughput. This stuff is all relatively self-explanatory, but you can see we have these little dots here that would show anomalies and events. So if I click that and then scroll down, it's going to show you the events that happened at the time of that dot. So we saw that the config was created because this stuff, again, happens on lab startup through that automation. And then you can see here, we started getting these anomalies. So let's click this anomaly. And we saw that the client round trip time deviated from the intervals and the means that we thought we expected. Transaction latency went up, open connections went up. You can go in here and quickly see what happened when weird stuff starts happening with your applications. And then you could have alerts based on these, or you could have scaling events and stuff happen based on this stuff too. Usually people don't get carried away with doing the automatic. So with being able to have the service engines be elastic like that, you can set up things called auto-scale groups, where if your application starts getting heavily loaded with traffic, we can automatically spin up more service engines to balance that load. You can use that. Most people don't, because you don't want the robots running themselves like that. Something like a Black Friday comes along, or somebody starts DDoSing you, you're in AWS, and now you just spun up 400 SEs and you get this giant bill. That's one of the reasons not to do it. But if you do have fairly tight control and good events and observability for that stuff, it's a very good way to scale up your load dynamically in response to something that's happening outside. So it happens based on these things. Also, since this kind of falls under analytics, events, being able to see all of the events that happened with the system. We checked out a license. We saw that we attached a virtual service, or we attached an IP to the virtual service. We had a scale out event when I was showing you the route increase, things like that. All that stuff's in here. You can stream that externally to syslog, Splunk, Wavefront. What do we call it? They call Wavefront something with an ARIA name now, but I don't have my cheat sheet to tell you what it is. So I had to make a cheat sheet a couple months ago that told me what all the ARIA names really mean. Hopefully all you guys have done the same thing. Yeah, so those are events. What else am I missing about analytics?
That's probably it.
Not much.
There's a lot of good information in there.
Yeah, it really is probably the biggest value add we bring to the table for load balancing is having all these analytics on here. It's a great feature.
Depending on your organization too, so a lot of people that we have deployed and migrated to, they will have their business units have read-only access to their specific tenant. So you put all their applications in that tenant, and then you give them read access to these analytics, these logs. So then they can get in and they can see what's going on. They can see if it is a network issue or if it is, an application or server issue, and then you never see that ticket. That whole mean time to innocence, letting you guys be more productive, not chasing server teams issues.
Any questions so far? Anything else you're interested in hearing about as far as the additional features, security, GSLB, Kubernetes?
One thing that was popular last year was when you were showing them the script automate, or how it spits out the Ansible.
Oh, yeah. So if you're network guys, you're probably, so I was a network engineer before I came to work at Avi. Very rare to find network engineers who are super into scripting. Most of them do a lot of things manually through the CLI. It's because it's hard and it's not something you natively think about. Avi tries to make it easy. So my first attempt at learning how to script, it was application modes ACI with Python. And I would say 95% of the difficulty in me learning Python was more trying to figure out what in the hell the ACI people were doing. You need to do LSD to understand that stuff. So Avi's not like that. Avi's got a pretty simple object model. We've actually got a built-in API Explorer inside the box. Built on Swagger. You can pick the particular API endpoint you want to look at, virtual service, you go in here and you can see, if I scroll some more, the model, all of the values that you can do in a virtual service, and there are a ton of them, are in here and documented. This is probably one of the best sources of documentation for Avi you'll get, because this is straight from the API. This is the way the product operates. It has to operate this way. So that's why these are such valuable pieces of information. Document on the web can go stale. This cannot. So one of the quick ways to go in here and see. So if you want to get started with Avi, the best way to get going in here is to go into the UI, create exactly what you want to create in the UI, and then you can go in our CLI.
And while he's doing that real quick, one of my colleagues, if anybody uses Postman, he wrote Postman collections that have all of our APIs in it for each version of Avi. Every customer we've showed it to, because he's demoing it for everybody now. I actually talked to some marketing people. We're going to try to get some blogs and stuff on it. But if any of you are interested in that, just hit me up afterwards and I'll send you links. It's available on GitHub.
So see virtual service in here, show virtual service. Actually, let me see if I can expand this out a bit so it doesn't look so janky. So the problem with this keyboard is the num lock is like where the backspace is supposed to be. I'm blaming Dell. All right, so this gives you a nice tabular view of your virtual service configuration. This shows a lot of stuff, including defaults and non-defaults. Not very useful for scripting, so we've got different CLI modes to help that. Do terminal mode script. Oh my goodness. Now, where are the arrows on this thing? Now you see it's all in YAML. You can take this YAML and with the addition of 2 more lines, put it into Ansible and hit play and it'll build the same thing. If you can't figure out scripting with that, then you're never going to be a scripter. But this, again, adds a ton of stuff. Another option, terminal. I think my thing just fell off my belt again. All right, now the show again. A much smaller list of things. These are all of the non-defaults. So, I think I broke it. Anyway, I'm just going to hold it for now. These are the non-default things. So all the default knobs that'll be taken care of or taken out of this view, so you have a much smaller Ansible blurb. You can do that with virtually any object in Avi and figure out how you need to script. So like the playbooks I have for this lab is just repeated blocks of these things that you've done the show in. Other thing you can do is you can go in, when you're making a request, you hit the submit on the virtual service in there. If you have DevTools open in Chrome, Firefox, whatever you use, it'd be too hard to show. So when you show it in DevTools, you can see the payload it gets posted to, and you can see the API endpoint we're using. Almost everything in the UI goes to a macro API, which is kind of more of an intent-based thing. When I use Ansible, I do step by step. So you need to do this thing, you need to do this thing, you need to do this thing. When you do the macro API, you put all that in a single JSON payload, and the API figures out the order of these things that are supposed to go in. When you do it my way, you get a very thorough understanding of the order of operations of things. When you do it the other way, it's faster and easier, but you don't know how to fix what you broke. So very easy to get up and running with automation in Avi.
I think that's it.
You think it's good?
Yeah.
Any questions on any of that stuff?
Yeah, we can definitely stick around if you guys have any questions, especially migration questions. I talk about that for hours.
Real quick, just because it is a very long lab, we do have a module switcher in here that will let you jump ahead to different sections. So if you only got through section 1 or 2, you can go in here and say, I'm running this SKU. I want to start module 3, click that button, it's going to run a big old playbook that's going to go through here and configure all the stuff you would have done in 1 or 2 so you're at the right spot. Just something to keep in mind. All right?
Yep. There are 5 Avi labs, so if you guys don't know, so there's the getting started that you've done. There's the GSLB, there's the second one. There's WAF for the third one. There is AKO and AMKO, which is 4, and then there is migration, which is 5, which has the F5 migration tool and NSX ALB to ALB migration tools. So if you could please fill out your surveys and let us know good, bad, what needs to be improved, that would be appreciated.
Thanks for coming.
Yeah, thank you very much.
Hopefully you learned something about load balancing.